There we go.
Hey,
Let me
I
get
don't know if
my
you can see me. I
thing
didn't put
on.
my camera on because but I can. It's not a problem. Um,
Uh, doesn't matter to me.
okay. Are you also streaming this live?
Yeah, I'm about to go live in a sec.
Nice.
I can figure this. Do this. Okay, there we go.
Do you go live very often?
Not really,
I
no.
didn't think you did.
Uh, let's see. My live isn't working. Okay, there we go. I think that's good. All right, cool. Here I am. Here is Jonathan. Do you go by Jonathan or JJ?
Jay is fine. Yeah, Jay's fine.
Jay. Okay, cool. All right. I'm here basically because I made a video about Kurt Vandenbosch and you responded to it on your live stream. And you wanted me to come onto your show so that we could have a chat, I guess. So, do you want to introduce yourself or say
Um,
anything
I, I,
about
I,
that?
I just wanted to say that I think we're two biologists trying to figure this out, and I did see you have seen your YouTube channel a few times, and one of my viewers brought to the attention that you had done another critique of Hert, and so I watched it, and there were a couple things that I think you got wrong, and so that's why I did the live stream about it, and some of my viewers then actually were the ones who emailed you and encouraged you to come on, and so I'm happy you did.
Mm-hmm.
Um, is there a particular place that you wanted to start? Did you watch the live stream? I mean, do you have particular points that you have contention with, or are you just
Yeah. So I
thinking
mean,
the
I
whole thing was wrong, or
yeah. So I watched the live stream. I guess we can run down any points if you don't have a particular preference for starting.
no,
Um, what's that?
no, go ahead, please. I would encourage you to do that because I think if you have a particular set of sticking points, it would be easier because I mean, I said what I needed to say in the live stream. I think the only thing I got wrong was that I said that Gerhardt was referring to natural antibodies as being the complement system, but it turns out he was talking about IgM.
Right. So we can start there. So
Okay.
IgM, right? So that's probably the one part of the video I wish was clearer, and I think it was kind of me not understanding what Gert was talking about. I'm just gonna call him Gert sometimes because that's what my brain does. I know it's hair.
Don't worry about it. That's
Um,
fine.
but but yeah. So I guess I'll just start by saying I was wrong to say or give the impression that there's no such thing as natural antibodies. What I was trying to really get across, and what I think Hurt really kind of got wrong, was this idea that these natural antibodies can neutralize and clear a SARS-CoV-2 infection all on their own. Um, so I guess I can explain the reasoning behind that if you want.
Sure. Go ahead. I know exactly where you're at, so I'll just go make your whole point, and then I'll try to counter or at least interpret it.
Sure. So thanks to how antibodies work in the germline, we have antibodies in our body right now that could recognize theoretically any epitope of any pathogen. That's due to hypersomatic mutation and shuffling of VDJ genes. But those antibodies are not from class switch mature antibodies. So they're typically really low in abundance and they're not going to be very good at binding. So you can detect them in cell assays. So there was a really nice paper in Science lately that was talking about germline antibodies that recognize SARS-CoV-2. So they exist, they're a thing, but as I said, they're in low abundance and they're not good at binding. So to expect them to neutralize and clear a SARS-CoV-2 infection on their own is not really good advice, especially when he says it the way he says it, as implying that a natural immune system can just deal with SARS-CoV-2 no matter what. That's the wrong impression to give. Uh, the antibodies need to undergo the B cells making the antibodies that might bind SARS-CoV-2 need to undergo class switching and further hypersomatic mutation in order to create better antibodies that can actually, do something more against SARS-CoV-2. IgM is typically not going to do much against a virus. So, yeah, a little bit of confusion on my.
In that point, I think the thing that you're missing there, or at least the point that Gerrit is trying to make, is that when T cells are responding early to infection, they aren't responding to spike protein epitopes. They're responding to the earliest expressed proteins in viral infection. And when they then activate apoptosis in those infected cells, there are viral particles and fragments of these digested cells and the viral particles that get digested by the macrophages that are there, that are then processed, and those need to be cleaned up. That's what the antibodies do in a natural, well done infection. The antibodies are cleaning up the viral debris. They are not the primary way that the body is stopping the virus from infecting cells. How would an antibody that's in your blood stop a virus from infecting the epithelial cells of your lungs? It won't. That's what T cells do. And when they fight the infection, they create debris which the body has to clean up, and that debris is oftentimes very much the same from infection to infection, and that's the reason why those IgM antibodies work at low concentration and low affinity. And the only reason why you need to enrich antibodies for specific epitopes is when the viral load reaches a level where it's systemic, and that doesn't happen with every infection because T cells take care of that. And I think most of the TV biology ignores the fact that asymptomatic infection in a healthy person is T cells responding to the first genes expressed in viral infection, and that's not the spike protein.
I mean, the spike protein is the first thing the body sees.
No, that's not true. The first thing that the body sees are the proteins that are presented on the HLA receptors when the cells are infected, and those proteins are viral proteins. That's how it works.
Including spike, but spike
it's the first proteins that are expressed. Spike comes afterward. You first have to express the proteins which hijack the cellular machinery of the epithelium, and those proteins must also be expressed on the outside, and they are the first T cell epitopes available. There's no other way to debate that. Those are the first and most prolific T cell epitopes. They are identified in at least 10 different papers as the most immunogenic epitopes in the genome, and that's because T cells respond to the earliest proteins.
Okay, so before we get on to that, just getting back to what Hert said, what you said is not really what he's saying. He's saying that antibodies can clear a SARS-CoV-2 infection, natural antibodies, IgM pretty much alone. That's not correct.
I think that you're parsing things out, and he's a 20-year immunologist, and he knows that T cells are the primary response. He's read all of Stanley Perlman's papers. There's 10 years of data from 4 different labs that made their careers on defining T cells as the primary response to any.
He doesn't seem to think T cells are going to do much.
He can't, because he's a vaccinologist. Don't you see? You're falling in the same trap that he's in. Vaccinologists have to look at antibodies because it's the only readout they've got. T cells.
No, you can measure T cells.
You can, but you can't measure all of them because the memory T cells reside in the lungs, and anybody that works on the immune system of a mouse knows that. You have to sacrifice the mouse to get the memory T cells. You can't measure them in a human. You have to get them when they're migrating.
You can get them from germinal centers.
You can get them, but they are not the memory cells. They are not the ones that are residing in the lungs. You can't. It's just not possible. You can argue, but there are no papers except for in mice.
There are. There's just a paper that was pretty recent, published in, where is it? Science, I believe, yeah, where they did that. They looked at longitudinal memory against SARS-CoV-2 in both vaccinated people and natural immune people, and they measured memory responses of B and T cells.
Right,
And
and
they
there's
found
stimulated memory B cell responses. That's not the same thing, and you have to understand
memory T and B cells.
They're not the same as the ones that are residing in the lungs. You just are unaware of the fact, maybe, that there are memory cells which migrate back. There are memory cells that stay from clonal expansion and from antigen affinity enrichment, and then there are also memory cells that reside at the site of infection. There are
germinal and in germinal centers, which you can definitely assay.
Right, but you can't assay the ones that matter the most, the ones that they only understand from mouse experiments and monkey experiments, because they can remove the lungs. They can sample from the lungs. You're arguing against nothing though, because you're still ignoring the fact that you're saying T cells, but that you're not admitting that they do the job. What other cells are getting rid of the infected cells?
Macrophages?
No. Macrophages don't get rid of infected cells the way that CD8 positive cells do, because they cannot target. They clean up.
Yes,
exactly.
They clean up.
So the primary response to any viral infection is CD8 and CD4 positive cells. Would you at least admit that? It's not antibodies. It's not antibodies, dude.
Well, no, antibodies are a frontline defense.
They are not a frontline defense because they do not reach.
If the titer is high enough, yes, they are.
That's exactly why the titer does not stay very high in a healthy person, because they are cleaning
if antibody titers are high, the virus will not be able to infect or spread very well.
Is that what you see in the data now? That antibody titers correlate with people who can get? That's ridiculous. You know that's not true.
We know that neutralizing antibody titers correlate with outcome and with infection and everything.
But you know that I've done like 6 months worth of streaming to show that that's not true. There are paper after paper, dude. You don't look at any papers. You don't show any papers in your streams.
What are you talking about? I link papers in every single one of my videos. Look.
But you don't interpret them correctly. It's kind of frustrating. You are trying desperately to sell the idea that antibodies are the thing, but they're really not.
Yep.
Would you like to hear?
They're really important.
Would you? But they're not as important as you think they are. Would you like to hear a virologist admit that? Like,
what are you talking about? They're
like a virologist say that they don't know what antibodies mean. Would you like?
They don't know what antibodies mean.
They do not know whether antibodies are a correlate of protection or not, and that's because.
So there's a difference there. Okay. A correlate of protection has not been determined for SARS-CoV-2. So that means that if you have really high antibodies from, say, a natural immune infection, and also really high but lower titers of antibodies from a vaccine, then that difference we don't know the significance of it. We don't know the immune correlate of protection, but we do know that higher antibody titers do correlate with better outcomes for patients.
It's very fascinating to me how convinced you are of this. It's very fascinating.
Okay, so what was wrong about that?
It's just that I can't find papers that show that antibodies to the spike protein are correlated with better outcomes. I just can't. Not the way that vitamin D is, not the way that zinc is, not the way. I mean, it's quite comical that you even laugh about that. I mean, the unhealthiness of America versus the antibodies of America. It's comical to me.
Okay, so the immune system needs to be trained in order to be best protected against these things.
It's never seen a coronavirus before.
Not SARS-CoV-2.
Oh, I see. And so what's so different about SARS-CoV-2 from the rest of the coronaviruses? Is it all the proteins or just a few? Do you even know?
It's very different.
How different? It's 61% different. And what's that 61%? Is it all spread out evenly, or is it found in certain proteins that are highly conserved across all coronaviruses? Or don't you know that answer?
I know that it's
mostly
60%, a
60%.
A 60% difference in the genome is huge.
It's huge unless it's not all spread equally, my friend. And it's not.
But
it's not. It's spread.
It doesn't matter.
It does, because the immune system remembers the genes that don't change, genius. There's evolution here.
It's clearly not able to recognize and clear SARS-CoV-2.
So how come 50% of the people? How come 50% of the people who get infected don't even get sick? Don't even know they're infected? How do you explain that? That doesn't happen with flu. That doesn't happen with. Does it? Do you get high viral loads of flu and not show symptoms? You do not. Sorry, but you don't. That's complete baloney.
You do. You do. It's very common to have an asymptomatic carrier of something. That happens.
It does happen. Yes, it does happen, but it's much more likely to happen now that we have these silly transfections going around.
What?
Yeah, transfections, the
Yeah, I know what a transfection is. It's a choice. It's a choice to call the mRNA vaccine a transfection.
It's not. That's what it is. It's not a vaccine. It's a transfection. Vaccines have an adjuvant and a pathogen in them. They have an adjuvant.
These mRNA vaccines have an adjuvant. It's the mRNA.
The adjuvant is an mRNA. They designed it specifically not to be immunogenic. Did you not read about how they did it?
Oh, I read about how they did it, and it does act as an adjuvant because they're able to purify it with HPLC that increases recruitment of dendritic cells to the site. They also pseudouridylate it, which also increases dendritic recruitment to the site. That acts as an adjuvant.
You are actually totally wrong. You know that, right? It's actually the opposite.
You're just saying I'm wrong.
No, but I've interviewed both Robert Malone and Luigi Warren. Luigi Warren is one of the guys who invented this. He's the guy who came up with the the idea of using this alternative. Wow, man, you are shocking me right now.
I mean, that's literally how it works. Pseudouridylation and HPLC purification increases dendritic cell recruitment.
Of what? Where at? You mean at the site of injection?
Yes.
Because the mRNA acts as an adjuvant.
Yes.
I would love for you to give me a reference for that. Because it's my understanding that the reason why they needed to use this alternative base is so that it would not be immunogenic. Because RNA is one of the most immunogenic things in the body.
Yeah, they went through a lot of trial and error.
Foreign mRNA.
Yeah, they went through a lot of trial and error to get this right.
To get it not to be immunogenic, and now you're telling me it's the adjuvant. It's completely wrong.
Oh, that's definitely how it works.
I've heard other people tell me it's the lipid nanoparticle. It's the adjuvant. You guys are crazy.
There
is no adjuvant. That's the whole point of this. If the mRNA was an adjuvant, you would have such a problem.
Okay, let me just get this reference for you.
Is it from Moderna or Pfizer, or are you giving me a scientific reference from pre-COVID?
No, this is a review of mRNA vaccines before COVID existed.
Cool. Send it to me, please. Do they talk at all about the fact that they had to reduce the immunogenicity of the mRNA, or how do they deal with
they had to try to figure out how to make it stable enough that the immune system wouldn't totally just chew it up right away. But
the immune system doesn't chew up mRNA, dude. You're a molecular biologist. You know that's not the immune system's job. There are just RNases that do that. That's not the immune system.
It's passive immunity.
Okay. Well, I mean, just don't say that's like the immune system. That's silly.
It's a defense against foreign invaders. That is part of the immune system.
I'm so confused. I'm so confused as to how this could be the adjuvant and also not immunogenic. I don't get it.
It's a balancing act.
It's not.
The immunostimulatory properties of mRNA conversely can be increased by the inclusion of an adjuvant, blah, 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 blah.
Inclusion of an adjuvant? You just said the words, you dope.
Oh,
What are
I'm
you
reading.
reading? Oh
I'm
my
finding.
God. You just read the words and you're telling me I'm wrong? Find another paper, dude.
Well, I mean,
Holy
you can
shit.
chill out, chill out.
Dude, you're starting to bother me because nothing you're talking about is right. It's the polar opposite. It's like you're just watching television, regurgitating it to me.
Yeah, that's a choice. So to call everyone you don't like TV scientists.
I'm calling everybody who's wrong. Everybody who says the same thing that PBS NewsHour says is a TV scientist. So I guess you are. I really want to be nice, dude, but this can't be true. You cannot have it
You're not really trying very hard to
You
be
cannot,
nice.
but you can't have it be not an adjuvant and an adjuvant, or not immunogenic and immunogenic. It's like you just read the article today and you don't understand it.
You can have it. It's a
You
balancing act
just
of two
read
different things.
the text that said mRNA can be added with an adjuvant, and then you stopped reading it because you knew you were putting your foot in your mouth. Are you kidding me?
I'm trying to look for the right paragraph.
Try to look. Try to look.
So
You should know it already because I'm talking about general principles of immunology, and that is that mRNA is immunogenic. And you're telling me that this is the adjuvant. That can't be true because otherwise the vaccine would not work like it's supposed to, which is expressing a ton of spike protein so that the body will build antibodies to the spike protein. It's one or the other, dude. It's crazy. It's like you work for Moderna and you're tripping over yourself to give a stock portfolio presentation.
Sure. Yeah, so that's exactly what they do. HPLC and pseudouridylation recruits dendritic cells.
What? That you just said the same thing you said before. You're not explaining
Yeah,
to me the biology of it.
It's in this paper.
What is the biology behind it, though? Explain that to me. How does that work? That the mRNA gets in disguised in the lipid nanoparticle, so then it doesn't attract the immune system and it expresses spike protein, and then it attracts the immune system? How? What's happening? Can you explain that? Because when a virus does it, a virus hijacks your cell's machinery, and the cells then signal out saying that I'm hijacked, both by presenting the proteins that they have to express and by sending out signals.
Yeah.
What happens here? Does it send out similar signals?
It's your body reacting to the foreign RNA.
I thought it was to the spike protein.
What? No, that's the recruitment of dendritic cells.
What is the recruitment of dendritic cells? The mRNA?
They're reacting to the mRNA, yes.
But the mRNA is in the cells. I thought the mRNA was in the cells. So then how is the...
It's foreign mRNA. Not all of it is going to be encapsulated in lipid nanoparticles. Some of it's going to be free floating.
Wow. Oh, this is all kinds of crazy shit that I didn't know about the vaccine.
Yeah, well, that's what happens in a tube. You don't have everything.
Then it doesn't stay in your shoulder either. It probably goes all through the body. It doesn't just stay in the shoulder. How could it stay in the shoulder?
It stays mostly at the injection site.
How could that be? I mean, you can't...
Because you're injecting into muscle, not the bloodstream.
But that's not what happens all the time then. If you hit a
vein,
injecting, or if you get close enough to an arteriole, then some of this stuff will pass into the blood, and then where does it go?
It's not going to go into an artery. It's getting injected into the muscle. It's very unlikely that...
How big is the muscle in a 5-year-old kid?
It's very unlikely that any significant amount...
Okay, but let's say that you injected 100 million people. What happened? Would it happen in 10,000 people then, or what?
Hold on. It's very unlikely that any significant amount is going to ever make it into the bloodstream. There have been biodistribution studies to show that that's what happens in animals.
Okay, so it does happen in animals.
What? No, what I just said happens in animals.
What, that it stays in the muscle?
Mostly, yes.
What about that biodistribution study from Japan? That was bullshit then?
Nope. Less than 1% of the lipid nanoparticle signal went anywhere but the injection site.
In that study, they showed that like 25% after 48 hours was in the ovary.
Nope. That is not what it showed. Relative to the total amount injected, it was less than 1% that went anywhere else.
Interesting. And you don't think that matters if it goes to the brain or to the lungs or to the liver or to the heart or anywhere else random?
They certainly didn't find any evidence that it matters.
In those animals?
Yeah. No tissue damage whatsoever.
I see. What about that paper that recently came out where they showed that when it does go IV, it goes right to the heart and it expresses in lots of places. So it could occasionally. So if we injected 100 million people and 10,000 times it actually accidentally missed and hit an artery, it would be a problem. Then you would agree?
You're not going to do that in injecting it into muscle.
But it does happen. I mean that if even
Can
it
you show
happens
that?
in one out of sure there's all kinds of forums where people are having all kinds of weird reactions to the vaccine that's supposed to be safe. Are those people all lying?
Show me the data.
Show you the data. You just have to go and find one of these groups on Facebook. There's thousands of people who claim to be damaged. Are they all lying?
Facebook's not data, dude.
Wow. Okay,
It's not.
so
Facebook's not data. That's like treating
VAERS.
VAERS.
What about VAERS? VAERS isn't data either, even though a doctor has to submit each of those deaths.
A doctor doesn't submit each one.
Of the deaths, they do. The doctor
No.
has to submit a death.
A doctor is not going to submit all of the deaths that are entered into VAERS. Sometimes it's a lawyer, sometimes it's a random person.
I see. So your belief is that the vast majority of those are crazy people, and so then we can ignore those 17,000 deaths. Is it just in America right now?
No, my belief is that you cannot trust the data at face value. You have to follow up on it.
Let's say that it was a tenth. Would that be okay with you?
A tenth of what? The total reported deaths?
Yeah, 17,000.
That's not what's shown.
What do you mean? What's shown? 17,000 people have reported to VAERS and over 18,000 in Europe. So let's say it's a tenth.
Yeah, and a lot of those VAERS reports are people saying that they're becoming the Incredible Hulk after vaccination.
You can pick out an anecdotal joke like that and then
you can pick out an anecdotal death like that too.
It's not. There are 17,000 anecdotal deaths then.
Yeah, they're anecdotes. You have to follow up and confirm them. You have to confirm that they actually happened.
Wow. Okay. So I'm sorry, but at this time, I'm going to have to say that we're not really making any progress. I mean, you're definitely not interested in anything alternative other than the TV. And I can clearly see.
Oh boy.
So I don't know what else to say. I mean, I hope.
There's lots more we could get to.
Whatever. Please let me know. I mean, I just feel like we're kind of spinning our wheels here because you just say no and I just say yes and we keep talking. I mean, you tried to prove to me that the mRNA, you understood how the mRNA worked, and then you just kind of didn't say anything.
Well, yeah, you're kind of yelling at me and we're jumping all over the place, but I'll show on my screen right here what I was talking about. So right here, strikingly, purification by FPLC has been shown to increase protein production from IVT mRNA by up to 1,000-fold in primary human dendritic cells.
So you're saying purifying it makes it more immunogenic, but that doesn't make it a more effective as a vaccine.
That's what a adjuvant does.
Yeah, but that's the point, right? That's the point. So how does that jive with the idea that Moderna and Pfizer told us that the mRNA goes and it expresses a spike protein, and then the spike protein, we make antibodies to it? How does the mRNA being an adjuvant figure into that? What does the body do with the mRNA then?
Are you asking how the mRNA increases the immune response?
If it does, what does it do? It signals it. Like, when you put an adjuvant in a normal vaccine, it's like a chemical, and it's a chemical irritant. And so they show up at the site. Listen, they show up at the site, and then they pick up the antigen that you've put in with the adjuvant. So in this case, you're injecting the mRNA, and some of the mRNA is expressing spike, and then the rest of it's attracting the immune system, and then the immune system shows up and pays attention to the spike?
Yeah, so you inject the mRNA. Some of it's in lipid nanoparticles, some of it's free-floating. The free-floating mRNA signals to the body that there's something foreign at that site. It recruits dendritic cells to that area. Once those cells in that area start expressing spike protein, the immune cells are there, ready to encounter it.
And so you think that that's the time frame. So you inject the mRNA, and then the mRNA irritates the immune system, and at the same time, some of the mRNA, some unknown amount, is entering muscle cells and expressing spike protein, and then a certain amount of time later, there's spike protein waiting for the dendritic cells that mature and show up there. That's what you think?
That's what happens. Yes.
That's what they tell you happens in
That's what happens.
that paper.
Because we see a robust immune response from these mRNA.
You see a
vaccines.
robust immune response in the sense of you see antibodies to the spike protein.
And cellular immunity.
What does that mean to you?
T cells.
T cells to the spike protein.
T cell immunity and yes.
To the spike protein. And B cell immunity to the spike protein.
Yep.
And so polyclonal immunity to you means multiple antibodies to multiple different sites on the spike protein.
That's right.
And so that's completely useless because only the antibodies that bind to the receptor binding domain will block and neutralize the spike protein, and the rest do nothing. And there are many.
That's not true at all. There's many ways an antibody can.
What do the rest do then?
They can opsonize.
And they can't opsonize unless they bind to a membrane. They can't do that if they bind to a protein. Then they can only aggregate. They can't
opsonize unless they bind to a membrane.
They don't work as an opsonin unless they're bound to a membrane. But you would know that. You should know that.
Spike proteins are membrane proteins.
Right, but when the antibody binds to the spike protein, they're bound to a glycoprotein, not to a membrane. And so that's a very different kind of signaling. And in fact, that makes the part of the receptor of the antibody unavailable physically because it's in between other spike proteins. And that's the reason why a lot of these off-target non-receptor binding domain antibodies are responsible for antibody-dependent enhancement like in dengue fever, which are also off-target glycoprotein antibodies made to last year's virus. But of course you know that, right?
Yeah, dengue experienced
but you know the mechanism, right? You know the mechanism is off-target antibodies to the glycoprotein, the exact same antibodies you're describing now.
There were 2 strains of dengue.
And you don't think there are going to be 2 strains of this? There's many strains of this. That's the reason.
It's not a one-to-one comparison. You can't just say that.
It's not a one-to-one comparison, but the mechanism is identical.
What? No, it's not identical. For dengue and SARS-CoV-2.
Off-target antibodies to the glycoprotein that allow the virus to enter other cells that it couldn't otherwise enter. That's
so are you saying that you're worried about antibody-dependent enhancement, or that we're already seeing it?
I don't know. I'm not in a clinic. I'm not running tests. I'm telling you that that's the possibility one of the possibilities that we're talking about. And the reason why making antibodies only to the spike and calling that polyclonal is incorrect. Polyclonal antibodies are to the N protein, to the M protein, to the E protein, to the spike protein. There are hundreds of papers demonstrating this from all the previous viruses, dude. Come on.
A monoclonal antibody is one antibody from one B cell.
Yes.
You have multiple B cells producing multiple different antibodies that recognize the spike protein in this case.
And if they all recognize the receptor binding domain, that's still only one major epitope. And
they don't all recognize the receptor binding domain.
But those are the only ones that matter. Those are the only ones that they measure.
No, they're not.
Okay, but it's
not the only one. It's not the only one.
I guess you don't really understand that then, because
they don't have to bind directly. Look, they don't have to bind directly to the RBD to neutralize. Even they can.
Yes,
bind,
they do. Yes, they do.
No. They can bind adjacent to it and then sterically hinder it.
If that's possible, yes, that's true. That's an option, but then you're still not talking the way that you should be, which is that there are a limited number of targets on the spike that actually neutralize it, and the rest don't. And you keep backpedaling, but not admitting this. It's the same shit with the...
This has been well characterized in studies such as this that I'm showing on the screen. I'll link it in the description for anyone who wants to read it. Lots of different antibodies, all able to neutralize and recognize spike or otherwise deal with it.
You're still focused on the same thing that Moderna and Pfizer would like you to be focused on, spike protein antibodies. You really imagine that that's the mechanism of immunity, and it's not. You're ignoring.
Of course, that's not all of it.
It's not all of it. It has to have CD4 and CD8 positive cells. You have to have CD4 positive cells coordinating the affinity enrichment of the B cells. You can't have the antibodies and the T cells are already singing.
Which it does. There is robust T cell immunity in response to these vaccines.
Robust T cell immunity to the one protein that changes the most in every coronavirus, the spike protein.
Which isn't an issue. It's not really an issue for T cells.
Oh my God. Oh my gosh.
Are you just going to keep saying, oh my God, or are you going to say stuff?
Oh, I am saying things. You're just ignoring it, right? I keep trying to
You're
explain
not
to you.
you're not really saying much. So what you don't think that this vaccine is going to produce robust cellular immunity
It doesn't.
against?
That's why people get infected more than once. That's why people are getting infected
Is
with a
that
more
why?
severe case after what's happening in Vermont and Massachusetts, Israel, Iceland. What's happening in those places? Why are those people? Why what's happening in the UK?
You're seeing cases go up, but no deaths. You're not seeing deaths go up.
I'm just, I
Look
don't.
at the UK. Look at the UK
It's not
graphs.
about deaths going up. It's about who's dying. The vaccinated people are now the preponderance of people dying in the UK. The
That's
last 6 weeks,
that's
75% of
that's
the
not
deaths.
entirely that's not entirely true.
It's not entirely true. Oh my
Not really. No. So you have two things going on in the UK. You have a lot of cases, yes, but you have very, very low deaths. The low deaths are thanks to vaccination. Now, the deaths that are happening, because there's so many people vaccinated, a good portion of those deaths are going to be in the vaccinated.
This is TV
But
biology.
if you break it down by age,
Is that how it
break
works with measles virus? That the more
if
you
you-
may vaccinate, then the more people get measles or are having vaccination? Is that how it works with measles?
hang on. If you break it down by age, you see that the lower age groups that are less vaccinated have more COVID cases and more COVID deaths than it.
And he explained that,
than the
Garrett
lower.
explained that to you, and that's because these people with a non-sterilizing vaccination can carry higher viral loads without symptoms, and therefore they can infect the people that are standing around them much easier. That's an easy explanation.
That doesn't check out really.
Of course it does. They
No,
have
it
less symptoms. You say it yourself. The vaccines keep people out of the hospital, but they have the same viral load. So I guess then
No,
they produce.
don't.
What are these studies that I showed in my live stream? Then are they lies?
I know. So okay, let's get to that. So you're talking about
The Wisconsin study.
right. So tell me, what did it measure?
Do I have to get it up right now?
Just from memory, you should know, right?
Oh,
That's
right.
what you told me. You should know.
Sure. Yeah.
You should know.
That's
Just
very sweet. You're
no,
very
seriously,
funny.
seriously, take your time, get it up, and let me know, what did they measure.
They looked at the viral load, as far as I know, PCR count.
That's not viral load. That's the important point to make.
Yeah, that's exactly right. So how does that work for your favor? How does that work for your favor? That they measured viral load as PCR count. Who's doing it any other way?
Well, not many people, which is the problem. So viral load is not a PCR count. That's
all
RNA.
we got. That's what everybody's doing.
Listen, that's viral RNA copy.
You don't have to explain it to me. I understand it. I did it.
But you're calling it viral load.
Because that's what they call it, and everyone else calls it like you. The TV calls it viral load.
That's wrong.
That's
not
fine.
Viral load.
So call it count then. How come they have the same count? How come they have the same cycle count?
Because there are lots of viral RNA copy numbers, but they're not necessarily shedding infectious virus.
Oh, and so that's what you can read from their data? That's how you interpret their data with your immunomythology?
Because
you have to take the data at face value, and there is no difference between those two groups in that paper. How can you differentiate between them? Just imagining?
Listen. So, in your paper, they are measuring viral RNA copy number at one time point. Then they go on and they measure infectious virus, but they don't really measure it really well because it's just a yes or no answer. They say,
so it's not suitable for you.
No, it's not suitable in general. So
what about the paper that you showed where it has this decrease down
to,
but you just ignore the fact that the ones that are still carrying a load actually carry a pretty stable load the whole time, but you just ignore those?
No, hold on. So in your paper, again, viral RNA copy number.
There was one from California you've got to debunk also, right?
Can I just...
Sure, try, I guess.
I'm trying. You keep talking, but it's viral RNA copy number in that paper. Then they try to measure infectious virus by just saying, does it cause cytopathic effects in culture, yes or no? That's not really good enough if you want to actually compare two different groups. So you can't really make conclusions that one group is spreading.
But you would make conclusions if the conclusions were ones that you enjoyed. You just don't want to make conclusions because they are not convenient for you.
No, I'll tell you what I want to see if you let me finish. So, the problem with that paper is you can't conclude that vaccinated, unvaccinated are equally spreading infectious virus. Now, what you would want to do is do either, well, I'll ask you, which two experiments would you want to do in order to determine that, to compare those two groups?
I want symptomology and only that. Sorry.
Symptomology.
Yeah, I think if you're not showing
Those
symptoms,
aren't two experiments.
I think if you're not showing symptoms, then we're all talking about mythology. I think that's one of the problems. That's
What?
one of the problems with this is that you like to use the PCR test when it's good for you, and then when it's not, you want to be instructive and say it's not viral load. It's cycle
It's not
count.
viral load. I've never said it's viral load.
I get it, dude. I get it.
Okay,
But
so what two experiments?
what two experiments would you do? Why don't you be the smart guy here?
I'm asking you. So it's okay. It's okay if you don't know.
Yeah, it's okay. I don't know. I want you to be the genius. What two experiments would you do?
Right. So you would need to do either a plaque assay or a TCID50 in order to determine what amounts of infectious virus either group is spreading so that you can compare.
And what
But that
plaque assay would you do? What
mean,
is
what
there a
plaque assay?
standard one?
A plaque assay is a plaque assay.
It's not. You have to have a background. You have to have a positive and negative control. What are you talking about? You're just pulling something out to try and look smart, right?
What are you talking? No, a plaque assay is determining.
How would you
amount of
decide
infectious
whether it
virus.
was? How would you decide whether it was one of the four endemic coronaviruses or this one? With sequencing, then afterward, after you do the plaque assay, or before?
Yeah, you would determine that
Because
the
these
infec-
PCR counts, none of them were sequenced. We don't even know for sure if these were any of the four original coronaviruses or this one, because we don't even know what three targets they sequenced for in this one. Right?
Are you saying that?
I'm saying that at least
Clar-
half of the
clarify-
PCR
clarify- are you-
tests, at least half of the PCR tests, unless you sequence afterward, cannot differentiate between the four endemic coronaviruses and this one. And that's been shown. That we know that.
No, that's not true.
It is true though.
No, it's
The WHO even admits it, dude. Why are you
do you
not
mean the
knowing
WHO?
this?
Okay, hold on. What do you mean the WHO admits it?
The WHO's policy admits that you have to sequence after you get a positive, or you cannot determine whether it's SARS-CoV-2 or not. That's
That is
already
not-
been like a thing for a year.
That is not true.
Did you
PCR
read the CDC
the P-
also says it. The FDA also says it, dude. It's in the EUA. You
That
haven't
is-
even read it.
That is entirely not true. So I have several videos.
I'm
talking
sure you
about
have
PCR.
videos talking about it, but you've got to read the documents, dude. Otherwise, you're just reading television and regurgitating what you saw on television.
I don't watch television, dude. So it's weird that you keep saying that. Okay, the qPCR for SARS-CoV-2 is specific for SARS-CoV-2. It was tested. There's an FDA document that I link in several of my videos where they go through and test it against all of the known human coronaviruses, SARS coronavirus, influenza, the gamut. And it only comes up positive with SARS-CoV-2. That's the power of PCR, is being able to differentiate between such closely related species.
And so you're convinced that all 246 PCR tests that were given an EUA by the United States in 2020 were all using the same primer sets?
Yeah, I mean, well, no, they're not.
No, they weren't though, because the WHO had their own primer sets, dude.
They're all specific. They're all validated in-house in every clinical lab.
That's the assumption you would make, right? That's the
No,
assumption you would make.
No, that's how the industry works. You have to validate each test in-house. It's very robust.
Very robust.
Mhm.
Like that's why they went out to like what? How many cycles did they use in the beginning for the first year? 45 or 40?
Right.
40? Was it 40? 42? Was it even 45?
It doesn't matter.
It does matter if you know how PCR works, dude.
I know very well how PCR works. So
Okay.
how about you tell me how it works first, and then I'll respond.
Well, PCR is amplifying the presence of any DNA, right? So first you have to convert whatever RNA is present to DNA, and you only get one chance to do that. So whatever RNA is there is going to get transcribed to DNA. I don't know the right word for that, reverse transcribed to DNA. And so whatever RNA is available, it could be endogenous RNA, it could be bacterial RNA, it could be viral RNA from any number of rhinoviruses, adenoviruses, whatever viruses are present in the sample you take. This is very different than the PCR that you and I do in an academic laboratory, where we take a very, very fine sample and it's very, very controlled only for the thing that we want to amplify so that we can prove its existence. I've done reverse transcriptase quantitative PCR to prove the existence of particular nicotinic receptors in individual neurons that I pulled out of the brain. And when I did that, I had to have positive controls for different subtypes of the receptor. I had to show that my primers all worked for those different subtypes. And for a lot of these tests, those have simply not been done. A lot of these tests do not have a positive control, for example, for any endogenous RNA. They don't have any controls for any regular everyday coronaviruses that should be present in some of these samples. And so as a result, whether you like it or not, there is a possibility for there to be false positives in light of the fact that we are testing people who are asymptomatic. Because testing on a low prevalence background is a very, very, very bad thing.
It's not, because Qpcr is so precise. So the way that it works in this case, you were talking about cycles, and that's pretty concerning that you're talking about it that way. I didn't think you would go there.
Explain it to me why that's concerning, because I don't think it really is.
Qpcr in an industry setting, in a clinical diagnostic laboratory, you're going to have a set of standards which act as your positive control. These standards are going to be serially diluted, and they're going to set a range, right? So, for example, if you're running a test for 40 cycles, and your standards set a range of 12 to 33. Any samples within that range are positive. Any samples outside of that range are going to be deemed either undetermined or negative. So it doesn't matter. That's why it doesn't matter how many cycles you run it for. The cycles are determined based on the standards you have and the platform you have and the specific way your lab is setting up the test.
And so the cycles cycles cannot be used at all. What does the Q stand for then?
I didn't say the cycles aren't used at all. I said that you can run the test for 60 cycles if you want. The range is still going to be the same.
I understand. So if the range of your indicator of being reasonable is between cycles 8 and 32, and they were using cycles up to 45, you have to admit that then those are all false positives, or many of them will be.
No. What do you mean they'd be false positives if they run the test for 45 cycles?
Because you're building up a fluorescence signal in your commercial test. Your commercial test is not a academic like yourself doing all the necessary controls and looking very carefully to see that the sample is reading the way it should be. It is a machine beeping at a certain number, saying that the fluorescence is at a certain thing, and they don't sequence it, they don't know. And so if you have a mRNA that was significantly overlapping enough to transcribe, you're going to get a positive in one of those three. And if they only make a positive in 2 out of 3 to make a positive, then you don't have a result. And they did this for millions of people without people trained as you are trained, without the skills that you have. These are technicians at best doing it as fast as they can to make as much money as they can. That's what's been happening in all the track and trace things that have been going on for a year and a half, because that's what all these private companies have been doing.
Okay, so you're saying something that's making me concerned again. How many measurements are taken during a Qpcr experiment?
For which? SARS-CoV-2? I don't know. It depends on which test they do.
Any Qpcr, how many measurements are being taken?
When I did it, I'm amplified like 20 different transcripts. I tried to do single cell PCR and amplified many different transcripts to see if they're there. So I was doing 20 experiments at once using 20 different primer sets.
So let me try to figure out how to ask this a little more clearly.
I mean, you're a molecular biologist. I'm a neurobiologist, so there's going to be things that, molecularly speaking, you're going to be able to make me look like a child, and that's fine. But you're not making me feel any better about your immunology or mine. I mean, I don't understand.
Okay. So if you have one sample and you run it in a qPCR test that runs for 40 cycles. How many measurements are you taking?
Presumably one.
You take 40 measurements.
Sure, you take 40 measurements, but at the end you have one sample. You don't have 40 samples.
No. So qPCR is done in real time.
Right, and it's in the same tube.
It takes a measurement after each cycle.
But at the end, you're done. You have a pile of your amplified product, right?
You don't just measure that pile. You don't just measure the pile.
No, but
you measure after
how the
every
fluorescence
cycle.
how the fluorescence changes per cycle. Sure, you get a curve.
Yes.
You get a curve that describes the change in fluorescence.
Exactly. And when the curve passes the threshold to being positive, that's what's recorded as the cycle threshold positive.
So what are you doing? Is this like a gotcha moment where you're trying to get me to explain how PCR works, and then now I explained it and now you got me? What is this?
You brought up PCR and started saying things about it that told me you're not really understanding it.
But I just explained it to you. Of course I understand it.
You didn't answer my questions very well. And
because I'm trying to explain it to other people.
You're talking about SARS-CoV-2 PCRs not being specific for SARS-CoV-2, and that's not correct.
Well, it's not correct in your mind, but I mean,
it's not correct in reality.
I can. After the stream, I would like to connect you with some actual other people that are doing this argument, that are molecular biologists making the argument that many of these.
Oh yeah, I'm in contact with a Dr. Lee. We're going to hopefully do one of these. The whole false positive narrative about these COVID PCRs is totally wrong.
I'm excited. That's good. I'll just let him do that then, because
if there were rampant false positives, we'd see very high PCR rates going consistently throughout the pandemic.
What? But why would we see that?
Because that's what we would see if it was rampant false positives detecting endemic coronaviruses.
No, but they're not. They don't have to detect anything. They just have to produce fluorescence in the tube. That's the point of the commercial test. If you don't sequence it, you don't know.
They only detect what produces fluorescence, and the fluorescence is based on the sequence.
Right. So if you have any primer dimers or anything else that could possibly produce a false positive, it's there. And if you've done enough PCR, you know that false positives happen, and you can't always explain them by the PCR is just so good and my primers were so good. How can this be here?
I do qPCR a lot.
On very clean samples, not from tubes that you take out of a nose.
No, I do it on crude extracts. And I have almost never seen a false positive. Actually, none of my negatives have ever turned up positive.
I can't.
It's just not common. It's extremely uncommon.
It's uncommon, but we're talking about hundreds of millions of asymptomatic people that were scanned for a protein that they probably didn't have, but might have had protein in the past. So how would you said it yourself, right? People
protein.
with mRNA. RNA. If they have RNA fragments from viral infection that are still there from weeks or months ago, whatever you said earlier, that vaccinated people can have RNA in their nose, but it's not infectious, and you have to do a plaque assay to figure it out. So then all of these asymptomatic people that were PCR'd could be put in exactly the same category as having mRNA that's not infectious, that was from previous infections, that it's coming up positive, and now you're shaking your head as though previous Mr. Wilson was wrong.
That's not how it works. You're not. It's really uncommon to detect previously infected mRNA in a person.
Then how are you using that as an argument to say that those viral loads in those vaccinated people aren't the same as in the unvaccinated people? That was the exact same argument you used.
What? No. Okay. Let's
what?
Get back
No. You used the same argument. You said that you have to do a plaque assay on the vaccinated people in order to prove that the PCR positive that they're getting is infectious virus. But now you're saying that there's no possibility of there being uninfectious virus in people.
What? No, I didn't say that. What are you talking about?
Oh my God, dude, you're lost. You are lost. I don't think I don't.
So
I gotta put my kids to bed. If you want to do this again, we can do it again. But it's not really. This is not really doing anything. This is just.
All right.
I'm
Okay.
giving up. I think you win. I hope that in a year we'll come back and talk to each other, and you'll still have the guts to talk to me because in a
Hang on,
year,
hang on, hang
yeah,
on. Before you go, I just want to say that let me sum up my point that I was trying to make. So yeah, you can't just take PCR copy number and say that that's viral load. You have to do a plaque assay
I
or
agree.
TCLD50. But all of these viral RNA copy number experiments, including the Singapore study, show that over time, vaccinated people clear the virus faster. This indicates that a vaccinated person would transmit less than an unvaccinated person. And if we look at epidemiological data, like what I have on my screen right now, that absolutely checks out. We see a very significant reduction of transmission from vaccinated people relative to unvaccinated
And
people.
the reduction in transmission is not to zero, and that's the point that Carrot is trying to make. That if you don't have a sterilizing vaccine, and
It
you
doesn't need
can't,
to be zero.
can you listen for a second? Then the vaccine,
And
that
yeah,
the viruses that these people are transmitting are viruses which thrive in the presence of the antibodies that you're so happy with, and that means everybody with this complement of antibodies will be welcoming of the viruses that these people do transmit. So even if they don't transmit for as long, the viruses that they are selecting for are the dangerous ones. And that's why Trevor Bedford's discoveries on next strain are so important, and you have to ignore them because the only
no,
proteins that are changing are the ones that go into circulation after transfection. And that's because then the immune system makes an overabundance of redundant memory to that protein, and that's why it's forced to change. You're going to
no.
see it. The hospitals in the United States will be full of vaccinated people in less than half a year, and you'll have to explain it with something other than the stuff you're talking about now.
Sure, we'll see if that prediction comes true. But let's see where to start. So you don't need to have transmission reduced to zero. That is not a goal of a vaccine. Nothing can
So that doesn't
reduce
happen with
transmission to
measles.
zero.
That doesn't happen with measles or with polio. They don't care
No,
about that.
polio vaccines actually do not prevent infection.
Is that true?
Yeah,
They
they
so
prevent
they
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 prevent
prevent.
paralysis and disease, but
Oh,
they
I
work
see.
really well.
I
They work
see.
really well.
These don't though.
They do. They do work really well. Because so what's going to happen in the case of an mRNA vaccinated person getting infected with SARS-CoV-2 is the virus is going to infect, it will start replicating in the host because vaccines do not prevent infection, they prevent disease. So if their antibody titers are not super high so that they can neutralize the virus before it can really begin infecting, then that's what you're going to have. You're going to have an infection. But as it begins replicating, the immune system will mount its response. Before the immune system actually mounts its response to clear the virus RNA copy number is going to get to a certain level. That is mostly not going to be selected for by your immune system. So if a vaccinated person transmits, which is possible, it's likely going to be in that period before the immune system has really responded and started neutralizing and clearing virus. And unless we have experiments to show that vaccinated people are in fact selecting for infectious variants that are uh, being affected by natural selection here, then you can't say that. You would need data to say that, but there is no data to say that.
Except for data that shows that the variants of concern are predominantly in vaccinated people, whereas the unvaccinated people have very random viruses. That
Mm.
sequence data is what is in Trevor Bedford's papers, but that's okay. You don't bother. Um,
I
thanks a
mean,
lot for talking to me, though.
you could show it to me.
I have. I did it on my stream. The links are there. Like, dude, you're so far from wanting to learn, and it's really I it's too much. It's too much friction. It's not a lot of fun.
Okay. You seem very upset, but I mean, the next
I'm
strain
upset
data.
because my kids are about to be transfected against my will because of dipshits like you thinking that transfection is the same as vaccination, and it's
It
not.
is a vaccine. It elicits an immune response. That's what it does. It's better described as a vaccine than it is a transfection. You're just trying to scare people.
Transfection is exactly what we've called it for 20 years when we've used mRNA to express proteins in other animals. Don't be a dumbass.
Yeah, but it's better described as a vaccine
Yeah, for the
because it
kids at
elicits
home,
an immune
because
response.
then we can indemnify all of the companies that are producing vaccines under the law that protects people that make vaccines. Dr. Wilson, thank you very much for joining me. It's been
Wow.
really great
Well,
talking to you.
I'm sorry. I'm sorry it couldn't be more civil. Uh,
I'm sorry, I couldn't do it anymore, folks. I couldn't do it anymore. I can't do it anymore. I could not. I couldn't do it. I wasn't very good at remaining calm, and I wanted to be, but when confronted with that level of arrogance, we are up against a lot, though, folks, because there are thousands of people like him in academia all around that think that they really understand this thing and think that the people that are doing this have our best interests at heart, that think that there's no profit motive here, there's no control motive here, there are no other motives here other than a pandemic and saving us from it. And God damn it, if it doesn't terrify me, that these are the people that we're up against. I'm sorry I didn't do better. I really apologize for that. It's also partly the way this is all set up. My Zoom is not really that great, and I can't share my screen with him because all of my stuff's here, and then I'm zooming with this other camera. And so all I hope is that whatever he could see from my Zoom was terrible. And so hopefully it looks really bad on his show or something like that. I don't know. Anyway, I apologize. I probably failed you. I'll be back again on Monday. I don't think I'm going to do a stream tomorrow because it's Halloween and I'm going to be out on the street with my kids, and I hope you will be too. I'm looking for the tubes. I'm hoping that there's going to be some people with some tubes. Last year I got a beer through a tube. We go to this neighborhood in Pittsburgh where there's a couple houses where I go by, and then there's always, Dad, you need a beer. And so this is like the best neighborhood ever. And so anyway, thank you very much for those of you who joined me. If you're watching it later, again, I apologize for the weird start. I apologize for my awkward behavior. I apologize for my lack of decorum. I got to get better at this before I interview other people. But again, taking on somebody who's clearly not interested in having their mind changed, but was interested in changing my mind and making me look like a fool, what would I do, and what experiments would I do? I hope that some of those points I was making were followable by you guys, and then maybe I'm going to watch this later and see what I did. Anyway, I'm just going to leave it there. I don't have any. I probably do have some music to play out on, or do I? Do I? No, I don't. Shoot. Anyway, I don't have any music to play out on. I'll see you guys again on Monday. Okay. Thanks a lot.